now because I'll forget. So we're recording and it will be posted to our website. So we have had 2 previous webinars. They're currently on our website. They're under the articles tab. So you can access those whenever you'd like, and we'll post this webinar on that same page as well. For those of you that are certified pesticide applicators, we were approved for applicator credits for this session as well as the next session as well. But there are a few things that you do have to do in order to receive those credits. So first, you had to completely fill out the registration form. So we needed your address, your home phone number, and either your pesticide applicator certificate number or your date of birth. So we need that information. You also need to be present for the entire webinar today, and you have to participate in the polls. So that's how we make sure that everyone's paying attention and following along. Caroline has some polls or a bit of a quiz for you today. So everyone will have to pay attention. If you have any questions about the pesticide applicator credits or anything to do with webinars, please feel free to reach out to me at any time. So I do want to say a quick thank you as well to the folks who actually made our webinar series happen. So we, as you all know, had to cancel our conference, and a number of people were able to donate their conference registration fees to us, which is what is allowing us to bring you these webinars now, which is really wonderful, and we're very grateful to those folks. So a big thank you. I'd also like to take a moment and just recognize our general sponsors. So we rely on the sponsorship of a number of organizations in order to do the work that we do. And so we're incredibly grateful to those organizations. Our sponsors for 2020 right now include Leduc County, Starland County, Colchester and District Agricultural Society, County of Newell, MD of Greenview, MD of Fairview, County of Grand Prairie, Lac La Biche County, Cypress County, Mackenzie County, Saddle Hills County, Strathcona County, MD of Wainwright, Woodlands County, Smoky Lake County, and Northern Sunrise County. So like I said, that sponsorship, it makes a huge difference to us, and we're very grateful for it. So thank you very much for your continued sponsorship. Memberships are another great way that you can support the Alberta Invasive Species Council. We offer both individual and organizational memberships, and they are available for purchase on our website. They run on the calendar year, and they're a great way to make sure that you stay up to date on all the latest invasive species news and current events like this webinar series. Okay, so I'm almost done. So today we're using Zoom, just like we have been for the previous webinars. And there's a few things to take note of. I'm sure most people are pretty familiar with all of these various online sharing platforms at this point. But just a few things before we get to Caroline's talk. So Caroline and I will be your hosts today, and we are the only ones that are unmuted, but that doesn't mean you can't communicate with us. So there's a couple of different ways you can do that. So if you, depending on what device you're using, if you move your cursor, you'll see a menu pop up on your screen, and I want you to find the chat button, and I want you to click on it. So click on the chat button, and you'll see a chat box will pop up. And so you can put comments in there, or if you're having technical difficulties, please put that information in the chat box. If you have questions for Caroline, what I'd like you to do is use the Q&A feature. So there's a menu on the bottom, and you'll see the Q&A button. So if you click on that, you can type your questions in there. So please feel free to use the Q&A feature. You can type in your question at any time throughout the presentation, but we'll wait till the very end to answer them. And then we will have a series of polls throughout the presentation today. So the poll will pop up on your screen, and what you're going to want to do is click on the actual answer. That's how you select it, is by clicking on the answer that you're choosing. So it should be pretty self-explanatory once it pops up, and we'll go through that again when we go through the first poll. So it's my absolute pleasure to be introducing today Caroline Whitehouse, who is a forest health specialist with Alberta Agriculture and Forestry. Prior to joining the government, she worked at the University of Alberta in a lab focused on the ecology of insects, including mountain pine beetle, forest tent caterpillar, and numerous agricultural pests. Her master's degree was focused on the reproductive biology of a cone-feeding insect pest in conifer seed orchards. Her forest entomology background provided the knowledge needed for her first role with the government of Alberta as a forest health officer in northwestern Alberta. Her current role is provincial in scope and uses her operational experience to complement her academic background. She helps to deliver a comprehensive forest health program focused on forest insects disease and climate change. And Caroline's actually a good friend of mine, and so I'm really excited to have her here today and to hear all about what they've been up to with the Forest Health Program. So over to you, Caroline.
All right, thanks Megan for that very unbiased introduction. and I appreciate the invitation to first speak at the AGM and now in this webinar series, which is kind of, this is my very first webinar, and it's kind of had me pondering whether or not if, you know, a presenter speckles their presentation with bad puns and terrible jokes and they aren't able to see people roll their eyes, are those jokes still bad? So perhaps that's one of the things we can answer by the end of this presentation. And I want to thank the audience, obviously, for attending. Aside from getting your pesticide applicator credits, I'm sure you have, you know, a general interest in invasive forest pests, knowing that they impact our economy, social values, and in many cases, the environment. So one of the advantages that we do have in Alberta is that we have a less than kind of temperate climate. And many of these invasive pests that are being introduced from other continents come from places that are warmer. And so we've got a bit of a leg up in that we have had a hot climate that's been inhospitable for the establishment of these species. So going forward, obviously recognizing that climate will be changing that, and we can still kind of keep that as a an aspect of pest biology in the back of our minds. The second reason why cold climates are kind of beneficial is, well, honestly, keeps out the poisonous snakes and spiders, which I am not adverse to. So hopefully by the end of our time together today, you'll be able to answer these 5 questions that your friends may, you know, have for you, knowing that you are interested in invasive forest pests. And so some of the questions we're going to explore today are: how are invasive species introduced, how you yourself can help prevent an invasion, what kinds of programs do we entail in the province to monitor for these potential introductions, who might be on our doorstep, and kind of in the same section, how are they or could they affect our forests if they are introduced. So I'll kind of cover 4 and 5 together when I'm going through and discussing some specifics about some pests. So the words alien, the words invasive, the words introduced are kind of like sometimes used a little bit interchangeably. And so I want to just be specific in that when we're talking about alien species, these are ones that have been introduced outside of their past or present range. And then really it's only once these introduced alien species become established and start to negatively impact biodiversity, ecosystem services, which then in turn, you know, impact our economy and our social values. It's at that point that they are kind of placed, given the label invasive. And you know, the movement of people and goods has really been increasing over the last, you know, 40, 50 years. And with this globalization, there has been a rise in the number of introductions intercontinentally, and estimates place, you know, about 1/3 of all the introductions that have actually occurred in the past 200 years have occurred since 1970. The rate of these introductions are not slowing down and are likely to increase, especially when we think about what I was just talking about, climate change. So climate change is opening up a new pathways for introductions to occur. So, you know, you can imagine that with the melting of the ice caps, all these Arctic shipping passages are kind of opening up, which then will allow the movement of goods from Asia to Europe to happen a lot more quickly, which then will also facilitate the survival of any hitchhikers that might be on those boats, thereby, you know, increasing the likelihood that they could be introduced and then established. In addition, once those hitchhikers arrive at the new continent, they could be experiencing these reduced thermal barriers due to climate change. And so, you know, they're able to maybe more rapidly acclimate to these higher latitudes because it's warmer. They may be able to outpace the native insects. And so, you know, there are a lot of dynamics around climate change and forest invaders. So when we think about managing an invasive species, technically, there's really sort of like 3 tiers to this. The first being prevention, just stop the invader from being introduced in the first place. The second, once an introduction does occur, then you want to detect it really fast. You want to respond really rapidly so that you have your best chances to actually eradicate or contain that forest pest. And then ultimately, for species that do become established, a lot of the effort is going to be focused towards controlling the spread of that pest, as well as mitigating the impacts that it would be having on our forests. And so really, unfortunately, a lot of attention is paid to the control and the mitigation aspect, which ultimately we know that if the introduction didn't occur in the first place, that would have been key. So that prevention is basically the best practice and the most cost-effective. So one of the questions that I have frequently been asked are mountain pine beetle considered to be invasive? And there's a couple of different ways we can kind of think about this. So if you look at the map on the left-hand side, you can see the sort of historical range of mountain pine beetle. It's the light gray area, and it extended from the interior of British Columbia down into the United States, following the range of various different pine species. Then we have the black shaded area, which is the quote unquote invaded area that extends into Alberta, you can see, slightly up into northern British Columbia, into the Yukon. Then you have these broken arrows, which kind of are showing the various pathways by which mountain pine beetle may be able to move into these eastern boreal forests. And in the US, you can kind of see that that broken arrow covers an area where there really isn't, there hasn't been the historic range for mountain pine beetle. And so we have these 2 ways by which mountain pine beetle may be able to move into these forests. But now, having said that, I wouldn't consider mountain pine beetle to be invasive because, number one, even though humans may have indirectly facilitated the expansion of this native species range, they haven't had a direct hand in it. So this is why, you know, in my opinion, I don't consider mountain pine beetle to be invasive, and rather it's a native insect, albeit a native insect that's behaving very, very badly, one that's undergoing range expansion. All right, and so as Megan mentioned, one aspect of our forest health program is really, I shouldn't say one, a big part of our program is focused on mountain pine beetle. And although I'm kind of going to focus on forest invaders for the remainder of the talk, we thought it would be a good idea to give you an update on mountain pine beetle in the province of Alberta. So the diagram there outlines our annual monitoring and control program for mountain pine beetle. So we just completed our 2019-2020 winter control program, and we're just now starting to collect data on the populations of mountain pine beetle, and this data helps us forecast what may happen into the coming summer with those populations and if they may grow or not. That data is still being collected, and so I don't have that. So we'll be focusing on the data that we collected in the previous year. So aerial surveys really form the backbone of our control program for mountain pine beetle. And so this really entails our staff and contractors flying over the forest, over the areas that have been prioritized for control work, and mapping red trees. And so these would be the trees that would have been attacked by mountain pine beetle in the previous summer. Those trees have now died, and the crowns are a red, brilliant red, that we're able to distinguish from older attacked trees. So in 2019, we recorded 245,000 red trees. This is an increase over the numbers that were mapped in 2018, although it's not really an apples to apples comparison, because the area of the province that we survey is directly related to where we know we're going to be doing control work, and that changes from year to year based on tree densities. And so you can see the 2 maps here. The 2018 map is on the left, 2019 on the right. And you can see that where that black arrow is pointing on the 2019 map, there's a large area where there are no trees mapped. And that's not because there are no red trees there. I think we all know, are pretty familiar with what's happening in the east of Jasper National Park. So there are red trees there, but those densities have just reached levels that are beyond what we could effectively manage with control treatments. So the main areas that kind of were responsible for the increase in red tree numbers, I have two black arrows pointing in the 2019 map, the eastern part of the Edson Forest area, as well as the spread of mountain pine beetle south into the Rocky Mountain House area. And indeed, the increase in Rocky Mountain House is pretty substantial. In 2018, we recorded 340 trees. And in 2019, we mapped 32,000 red trees. All right, so we take the red tree locations and we then use those to locate where we're going to go onto the ground and conduct these green attack to red tree surveys. So green attack trees are the ones that have been just attacked in that summer. These surveys being conducted in the fall. And then we count the number of green attack, count the number of red attack, and then that provides us with a ratio of population that indicates population growth within that season. And so you can see from the table that in 2019, a value of 0.8, which is much lower than had been in previous years, which may seem counterintuitive given the increase in the red tree numbers. However, I'll be able to discuss that in depth in just a slide or so. And so on the 2018 map on the left-hand side, we see this large area of high population growth in the central region. And in 2019, that region of population growth had really contracted. So that's a very good thing. In addition, we see some pockets of high population growth kind of up towards Grand Prairie, and near the British Columbia border, as well as around Slave Lake. So then our next major activity is the single tree treatment program, where we cut and burn mass attacked mountain pine beetle trees. And so this is really the most effective way to treat mountain pine beetle on the landscape scale, such as what we do. And so in 2019, we controlled 105 million trees. Excuse me, 105,000 trees. There'd be so many more. Anyways, and that's about 4,000 more trees than we had treated in 2018, and it cost us $30 million to do that. Since 2006, we've controlled 108 million trees. And so I think that there's about 4.5 million people in Alberta with 1.8 million trees controlled. So over the scale of over the time frame of the program, we've controlled about half the tree per person in Alberta. So what is predicted for this population? What is the population going to do coming into this next season? So as I said, those population forecast surveys are happening right now, and we'll have that data in a couple of weeks. So there are a couple of things about mountain pine beetle biology that is really important to consider. So temperature highly regulates and impacts mountain pine beetle development and biology. And in 2019, unfortunate for us, we had a very significantly cold snap during March 2019. This was then followed by another cold snap in January 2020. So this is the single most significant source of mortality for mountain pine beetle, and to have these much colder than average temperatures would go a long ways towards causing even more overwinter mortality. Then the summer of 2019 was also cold and rainy, and this is something we don't think about quite as much, but that influences how fast the adults will emerge from their trees and reproduce. And so we know that flight was delayed by almost a month in some locations, which then led to the offspring which were produced being younger going into winter. This is important because those life stages are more vulnerable to cold than more mature larvae. Additionally, fewer offspring were also produced. So it's just really important to consider pest biology when you're thinking about managing, you know, any insect, including those that are invasive. And so this brings us to actually our first poll. And so I'm just gonna launch that. And so the first poll, the question is, which is the best approach for managing invasive species? Is it prevention? Is it eradication and containment? Is it control and mitigation? Or is it none? Just let them run their course. And so we'll wait for about 80% of you to vote, and I see you're all very rapidly voting, so I appreciate that. That's great. This is my very first poll, quite exciting. And so we'll just, got just about 10% more people to go, and then I'll be able to show you the results. And it seems like you are all so far quite keen. And so that's great. So I'll end polling now, and I'll be able to share the results. And I'm so happy to say that 93% of the people who answered got the right one. And one person thought that we should just let them do their thing. So that's great. All right. So now let us move on to the next section of the talk. So this is kind of the main bulk of my talk. We're going to discuss forest invaders. And the first aspect to really consider is, well, how are forest invaders first off introduced? And you're going to see a theme here. And so transport by humans is the main vector for the intercontinental movement of invasive species. And, you know, if you look at this shipping, this boat carrying all these shipping containers, you can just imagine the myriad of locations that invaders could be hiding on these ships. So egg masses laid on the outside of containers, inside of containers, inside little, you know, protected spots. You could have adults that were previously contained now running around in the containers themselves. You could have larvae like this large Asian longhorn beetle, you know, burrowed into the wood packaging material if it was not appropriately treated. And as well, I think we also are quite familiar with ballast water, and which has been a main vector for the transport of aquatic invasives from, you know, one country to another. So there are protocols that are in place to reduce the likelihood that an invasive species is going to be transported intercontinentally, but these introductions are still happening. So federal regulation is primarily responsible for the movement intercontinentally of invasives, and this really isn't my area of expertise, but I definitely needed to include it. There are a series of policies and strategies that are aimed at limiting the introduction of invasive species. You know, there would be entry requirements for, you know, wood packaging, you know, the requirement for inspections of plant material, so when it's being moved between countries. So yeah, so there is federal regulation that is addressing this. But domestically, again, the main vector of a transport is really by humans. A lot of these invasives are wood borers or defoliators that can easily lay their eggs or, you know, be hiding in material and make it difficult for us to see. So you can kind of see the picture on the top left there are of gypsy moth egg masses that have been laid on the interior of, or the backside, I should say, of wheel of a recreational vehicle. So person A takes their recreational vehicle from Ontario, they don't inspect it, they jump, you know, hop in, attach it to their big trailer, drag it out to Alberta, and voila. You know, during the summertime, we have the emergence of gypsy moth larvae. Could also, emerald ash borer is a wood borer, and it has been transported here initially to the country by wood packaging material, but then spread. It has subsequently occurred through firewood. And so really it's the domestic transport of humans that increases the sort of leading edge of spread of invasive species once they've arrived. And the firewood pathway has really been identified to be the biggest risk that the country is faced with when thinking about the movement of invasive species. And so often, you know, less desirable or already compromised trees are the ones that are being harvested for firewood. They may already be down on the ground, and they increasing kind of the likelihood that they're going to be infested by, you know, wood borers and the like prior to harvest. And then even, you know, once the firewood, if it wasn't even infested initially, then that can be, you know, infested readily by wood borers once it's been cut and sitting there green and fresh. And so it's this green, fresh firewood that hasn't been treated that really poses the greatest threat. And firewood can be really moved very long distances, which then, you know, gives these species a good chance to jump, you know, between provinces. And in particular, actually, the rapid expansion of emerald ash borer has been closely associated with the movement of firewood from recreational campers, and that's depicted by the map on the left here. You have the movement of campers and firewood from within the quarantine area in the United States up into the uninfested regions of Manitoba, Ontario, and Quebec. These have been significant sources. And actually, the Asian longhorn beetle was first discovered in Chicago when a citizen noticed that a beetle was actually emerging out from a piece of firewood. So, as I said, phytosanitary regulations have been implemented requiring the either kiln drying or the heat treatment of firewood, but we know that this doesn't always happen, and unfortunately, recreational campers can sometimes be an important vector. So, you know, recognizing the risk associated with firewood has kind of garnered this big education and outreach effort. And so, you know, continental-wide, there are these various jurisdictions have adopted these don't move firewood, burn it local, burn it, or buy it local, burn it local kind of campaigns, trying to educate the public about the concepts of the regulations and some of the best practices surrounding you know, the movement of firewood and its pathway as a vector for harmful forest pests and invasive species. So in Alberta, we do have regulation that deals with the flow of timber and wood fiber products in and out of the province. So the import and the export directive. The export directive really is more focused on the economic aspect of fiber flow rather than really addressing the risk of us, you know, the potential for forest pests to be moved from Alberta into another province. That relies on that province's import policies, of which, of course, I mentioned we have a directive on the import of logs and forest products with bark attached. And so initially the directive was really addressing conifer import, and it was in recognition of the potential for mountain pine beetle to be transported from BC into Alberta. Recently, we were able to expand this to include deciduous trees as well, just in recognition that deciduous is an important component of the harvest for some other provinces, and the risk that is posed by the invasive species that could be infesting this deciduous wood. So this has been a good move forward for the province. So so I think the next part of the discussion will kind of focus on what sort of monitoring programs that we have in place to help alert us to the potential for introductions to occur. And so monitoring in Alberta is primarily a collaborative thing, and we partnered with Canadian Food Inspection Agency as well as the Society to Prevent Dutch Elm Disease. to monitor for invasives. And essentially, these two agencies provide us with trapping material and identification services. And we provide the boots on the ground to get the traps out and to monitor and collect the trap catches. So we really focus the monitoring at these high-risk sites, and by that I mean places where you have a large number of visitors or kind of transient traffic from other areas of North America. This, could be represented by campgrounds, even additionally industrial traffic such as rail yards. These are the sites that you want to really focus your identification or your monitoring efforts on. So with the Society to Stop Dutch Elm Disease, StopDED, we are focused on monitoring for wood borers, as well as Dutch elm disease vectors. And for those maybe a little less familiar, Dutch elm disease is a fungal disease that infects only elm trees. It was introduced to North America in the 1930s, and it moves rapidly from infected and weakened trees on the bodies of these introduced and native elm bark beetles, one of which this you can see in the center picture. And it's a very acute killer of elm trees. And so Alberta is important because we're one of the last 2 locations in North America that are currently free of Dutch elm disease. And so during these surveys, we're looking for, wood borers such as the Japanese pine sawyer beetle, which is on the left-hand side, as well as Cyrix noctilio, which is a wood-boring wasp that's it could be quite invasive if it enters into our forest. We use pheromone-baited funnel and as well as sticky traps for these monitoring projects. So our gypsy moth monitoring is done in conjunction with the Canadian Food Inspection Agency. And so we generally, I think, place out about 80 to 90 traps on behalf of CFIA. And again, we're monitoring in these high-risk sites, and we use these green delta traps, and they're baited with a sex pheromone that would attract the males to these traps, which would then alert us to their presence. You can do 2 types of surveys, monitoring and delimitation. So if there is an incursion, then these are followed up with these delimitation surveys, which then are performed in a grid, a very intensive grid, in order to find out if there are actually any established populations around that incursion. So now we're going to go to poll number 2, and all right, and so I believe you should be able to see it there. So which material is the most important for vectoring invasive species domestically? A, shipping containers, B, firewood, C, pool noodles, or D, wood packaging. And we've got lots of people. You guys are right on this. I'm very, I see a trend here. Pool noodles, just letting the invasive species go. We've got 1 vote for pool noodles. Whoa, 2 for wood packaging. And we're getting close. Just need a few more people to vote. We'll get to 80%, and then we'll be able to close the poll. All right. You are very fast on this. And I didn't even have to tell you that you can click on the screen, which I was supposed to do. And so I'm going to share the results here. And by far and wide, you are all still paying close attention and are recognizing that firewood is one of the most important vectors for moving invasive species domestically. Nice work. All right, okay. So this is going to form the remainder of the presentation, and it's really going to be a discussion of who are the invasive species that we're kind of on the lookout for. There are a number of them that I could review today, and I would kind of love to just like bomb you with a series of pretty pictures and Latin names. However, that's not the most useful task, so I did try to narrow it down here. And I took a look at the Canadian Food Inspection Agency list of regulated pests. And so this is just some of them. that are on our radar. And likely you'll be able to recognize the pretty but destructive emerald ash borer, the third beetle from the left, as well as the gypsy moth, second from the right. But some of them may be less familiar to you, such as the common pine shoot borer, which is the beetle kind of like right in the center there, which is a relative of a distant relative of the mountain pine beetle, as well as the citrus longhorned beetle, which is the second one from the left. So these are just some of them that are kind of on our radar. But these are the three that I'm going to really focus on for the remainder of the talk. And I am an entomologist, as Megan said, and so my bias is, of course, always discussing insects because I think that they're so fascinating, but I must give some airtime to diseases as well. And one of the important ones in the province here is white pine blister rust. So we'll start with discussing white pine blister rust. So it was, there we go. Okay. So it was introduced on imported seedlings from Europe to New York in 1906, and then again to Vancouver in 1910. And its spread has been quite slow across North America. And disclaimer, this is like basically the only pest that I'm going to discuss that really isn't moved or vectored by firewood movement. And this is kind of important to consider because it has this really complex disease cycle, essentially life cycle, where it requires an intermediate host in addition to its pine host. And so it has been really historically thought that ribes, like currants, were the only intermediate host for the blister rust, but we now know that that's not true, and other species such as paintbrush as well as snap dragons can also function as hosts. So it has, like I said, this complex life cycle, and the rust takes a number of different forms and uses these two hosts throughout its life cycle. So the infection in the tree begins in late summer and early fall when these fungal spores from the diseased intermediary host land on the pine needle itself. These needles germinate more rapidly during a nice wet summer. And the spores germinate, and then these hyphae move into and colonize the needle. So then the fungus kind of grows from the needle into the twigs and into the branches, and this can, occur over a couple of years. Then in a spring, after a few years of the initial infection, these blisters that you kind of see here in the center will then, over here, burst through the woody material and release these orange spores, which are then carried on the wind and infect the secondary host leaves. And then these basidiospores are produced by the infected secondary host in the late summer again, and these are the spores that then are transported on the wind and land on the needles to begin this cycle again. So symptoms of white pine blister rust. So there are a number of things going on in this picture, and we'll kind of start over towards the left here. This is towards where the branch would be attached to the bole of the tree. And we have in the center here an active canker. So we have the sacs that have burst, the blisters that have burst through the woody material, and you can see the characteristic orange spores on these sacs. A little bit higher up, you can see empty spore sacs that are kind of just white now, and then this sort of diamond-shaped kind of canker in total, which is the active canker. Further up the branch, where flagging has begun, that meaning that the branches have started to die back, we have the presence of an inactive canker. So that would have occurred earlier on in the infection cycle. We have some bark stripping. Rodents are really attracted to the cankers and like to gnaw on them, so that's also evidence of the canker itself. And yeah, and so overall the tree will start to take on this kind of like raggedy form, just given the amount of, you know, branch dieback as well as crown dieback. So why do we even care about this blister rust? Well, for us in Alberta, it affects, well, everywhere it affects 5-needle pines, but here in Alberta, our 5-needle pines are whitebark and liver pine, and these are high elevation keystone species that are, you know, provide essential food sources through their big fatty seeds for a number of different high elevation species such as grizzly bears. And they're a very long-lived, slow-maturing tree species, and the cone production kind of typically occurs at the edges and ends of the branches, which are susceptible to, you know, the infection by the blister rust. And these two species are actually considered endangered in Alberta. Number one, there's 4 main threats. One being obviously the blister rust, the mountain pine beetle, which are capable of mass attacking and killing these trees, fire and fire suppression, as well as climate change. And so they're already challenged and these challenges can also interact and exacerbate the effects of each other. So crown death is really common, and with that comes then the end of seed production, which then essentially ends their key function in their habitat. As well as, you know, without seeds, then it's difficult for a species to also naturally regenerate. So how do we manage for blister rust? Well, we know eradication is really not possible for this disease. And so the focus is then on disease resistance. And central to this are plus trees. And these are pines that kind of appear to be free of blister rust or are much healthier when compared to disease trees that are adjacent to them in the stand. So these plus trees are permanently field marked, and then they're documented for ongoing health monitoring. There's also genetic materials are collected from them, like seeds and scions, and these branch cuttings are collected and grafted onto rootstock to help establish a seed orchard, as well as a clone bank. And then the seed can also be used obviously for seedling growth. And if mountain pine beetle presents a risk in that area, then they're also protected by mountain pine beetle on an annual basis. So as I said, disease resistance is the main focus for managing and controlling blister rust. It's that third tier, right, of our approach to how we deal with invasives. And so this is a collaborative effort between our government and the United States Forest Service, as well as the BC Ministry of Forests. And so essentially seedlings, whitebark and lumber pine seedlings are exposed to the blister rust teleospores, and then they're grown out for several years in these nurseries, during which time their susceptibility to the blister rust is assessed. This is a really long process, and testing will span a 7-year time frame. So results are pending, and but I know that we've had some good preliminary results with our genetic material. So that's kind of the story of blister rust and pathogen. And now we can move back into the area that I'm a little more comfortable with. Gypsy moths are going to be our next focus. And I say gypsy moths because there are 2 subspecies, and I'll discuss why that's important a little bit later on. So obviously the European is indigenous to Europe, and the Asian to Asia, as well as their are populations in North Africa. They are, these species are able to use a broad range of host plants, and you know, it's this ability to use this range of plants, along with really high reproductive rates and their proclivity for laying eggs on human-made objects, that has earned them a place on the world's worst invasive alien species list. So the gypsy moth life cycles will be similar between the 2 subspecies, and you know, they undergo 4 stages of development. They go from the egg to a larva to a pupa, and then to an adult. And so we'll review that now, and I'll also give you some information about how you can identify gypsy moths. So these eggs on the far left-hand side here are laid in clutches, can range from 80 to 120 on branches and trunks of trees or other objects. You can kind of see it has a little bit of a fuzzy appearance, and that's because sort of little furs from the female's abdomen have been rubbed off onto the egg mass itself in order to, they guess that it's to maybe provide some protection against predators, parasitoids, as well as maybe a little bit of an insulator and keeping moisture in the egg mass. So the larvae, and this is the stage that they overwinter in. So in late spring, early summer, these larvae will hatch out of the eggs, and they will molt, go through 5 to 6 stages of development. These later instars make them very easy to distinguish from other related caterpillar species. And this is so the main characters will be these spots on their back. And so you'll have 5 sets of blue spots that are closer to the head, followed by 6 pairs of red spots closer to the hind end. And they're also covered in these little urticating hairs. And those will, if you come into contact with the gypsy moth, they'll rub off on you and be very irritating and can cause a lot of rash and skin issues. So the stage in between the caterpillar and the adult is this pupal stage, during which time they undergo complete metamorphosis. And so these, the pupa are these little dark brown, cases that are kind of have some of the matted reddish hairs, urticating hairs on them, and they will be attached to objects with a bit of silk. So the moths will emerge from that pupal stage, later in the summer, and the 2 sexes are sexually dimorphic, because that's obvious. And so you can see on the left or right-hand side, we have a little brown moth, and that's the male. He'll have little kind of feathery antennae. And then on the left, the larger white moth with the dark markings, that's the female. So the adults are not very long-lived. They have about a week within which to kind of get busy. The males generally emerge first because the females are ready to reproduce as soon as they, emerge. So so they have about a week to lay their eggs and get their business done. So some of the symptoms and signs that you would see of gypsy moth, well, you would see the larvae feeding, and the defoliation would kind of look like little holes in the leaves with large areas being defoliated. And then this would be followed by the presence of these egg masses that are kind of spongy, and you may well see the females laying those eggs as well. So those are the primary symptoms and signs of gypsy moth. So the difference between the subspecies that I mentioned, and this is pretty important for us to know, and generally whenever gypsy moths are trapped, say like in British Columbia or say in Alberta here, we would do a genetic analysis would be done on them to determine that they are gypsy moths and which subspecies they might be. Because this is really important, because in the European gypsy moth, the females don't fly, and so it makes them slightly less invasive because they're just not as good at dispersers, although the males and the larvae are able to disperse in both of the subspecies too. But in the Asian gypsy moths, the females are really good dispersers. They can fly up to 20 miles. So this really gives them much more capacity to expand their range more radically. There's also some evidence the Asian gypsy moth is more cold tolerant, giving it that ability to invade higher latitudes. As well, it appears that they are able to use even greater number of hosts than the European gypsy moth. And you can kind of determine the difference between the two if you don't happen to have a way to do that with DNA. You can look at the wingspan, and the Asian gypsy moth is basically basically 2 times the size as the European. The impact, well, 595 million hectares of forest are susceptible to gypsy moths, and you know, it's this broad range of tree species that make up a lot of the canopy of the forest, urban and you know, our forest ecosystems. And so because they would, you know, would be defoliating these trees, they would be, you know, their repeated defoliation would cause the crowns to thin. It would weaken the trees, which would make them susceptible to other pests, which may be the ones that ultimately, you know, kill the tree. But they would outcompete, you know, our native defoliators and kind of interrupt nutrient cycling of the forest. In the US, in 1998, between 1998 to 2007, it's estimated that the property value losses were, you know, upwards towards $120 million US, and almost $3 million in management costs. And so that's quite expensive, and there could be better uses for those dollars had it not been introduced in the first place. So how would you even manage and control gypsy moth? Well, you kind of have couple of options, mechanical and biological. Mechanical, you would essentially like find those egg masses and scrape them off, squish larvae. You can also like apply burlap and sticky bands around the trunks of host trees, which would then kind of the larvae, as they're, you know, moving around, would then adhere to the sticky bands. But these really are not going to eradicate gypsy moth. They're primarily used to keep populations at manageable levels. So in Canada, we have used Bacillus thuringiensis. It's a bacteria as a spray treatment. And this is kind of used just over public areas. Obviously, it's expensive to do. I'm not sure how feasible that would be to do over the working forest. However, you know, we don't have to answer that question at this point. In British Columbia, they've utilized it in a very aggressive trap and spray program, which means BC has been able to keep populations, you know, basically eradicate them. There's also an Entomophaga. It's a fungus that's present in the native range of gypsy moths, and it was used in the US actually to cause mass mortality. And then there's this nucleopolyhedrosis virus, again, also present in the native range. And in Canada, we have incorporated this into a biological pesticide, and it has been successful as well. So the movement of gypsy moth, as I mentioned, it can be windborne with adults, larvae, fly on silk, and it's vectored by humans. And so once you have, you know, these established populations, movement restrictions are put in place by the CFIA in order to limit infested material moving to other uninfested areas. And a couple of things that you can do. So if you happen to ever be, you know, in the southern areas of Ontario, Quebec, or the Maritimes, and you have taken a vehicle out there, just be sure to inspect your vehicle before you return to Alberta, destroy any, you know, egg masses that you may see. And in addition, my theme, don't move firewood. So in Alberta, we've had two positive trap catches of gypsy moth. They were both the European gypsy moths, and these were, I think, 2014 and 2015 in the northeast part of the province, one in a provincial park and one in an oil and gas work camp. And so it's likely that travel equipment was brought from out east, and there were likely egg masses hitchhiking a ride on that equipment. So subsequently, we've not had any other incursions of gypsy moth, so that is very good. We do not have populations of gypsy moth in Alberta as of 2018. So our final insect of focus is going to be the Asian longhorn beetle. And so it's indigenous to China and Korea, and interestingly, its prevalence in those countries and its range in those countries increased because of this widespread planting of susceptible poplar hybrids. It does feed on a wide variety of hardwoods that are prevalent throughout our urban forests, and one thing that makes the Asian longhorn beetle a little more dangerous than other kind of closely related cerambycids is that They all attack stressed trees because it's easier to overwhelm the defenses of the trees, but they also can attack healthy trees. So this definitely presents more of a risk and a likelihood that it could establish. Its life cycle, just like the gypsy moth, it has 4 life stages, and we'll go through those here. So the top left-hand corner, we have little rice grain-sized eggs. And the female, what she does is she chews out a little pit on the bark of the tree and lays an egg. And so she can lay an egg at multiple sites in the same tree. Ultimately, she'll spread those around different trees, up to maybe 100 eggs. They'll take, you know, depending on a week, the temperature, excuse me, they'll take up to a week or a couple of months to develop. So the next life stage is the larval stage, this little fierce-looking guy here with very substantial mandibles. So initially when the larvae hatches from the egg, it'll just kind of burrow just right under the cambial, or just right under the bark, under the cambial region of the tree. Eventually, as it grows larger, it'll tunnel right into the heartwood. And so it's this larval feeding, which then cuts off the water and nutrient transport systems in the tree, which then leads to the death of the branch, or, you know, ultimately the tree itself. The larvae are the ones that overwinter in the tree, and then adults will emerge, then they pupate in early spring with this kind of really interesting alien looking pupa. You can actually see the long antennae. I'm not sure if you're able to distinguish that in the photo that I have on. Quite interesting looking. So then they go through the pupal stage, and then they emerge as adults in later summer. And they pop out, the adults chew out of the tree via this exit hole that could be about 2 centimeters in diameter. So to identify Asian longhorn beetle and the tree symptoms, got a couple of clues here. So the beetles themselves are black and shiny. They have these very long black and white segmented antennae, and they have this kind of distinct bluish white tinge to their legs. They're about 2 to 4 centimeters in length, so quite large. And as for the tree, you'll see the presence of these egg pits, and just below that, the person's finger there, you can see the exit holes. As well, the tree itself, the leaves will start to yellow, particularly the branches that have been directly affected, as well branch dieback that you'll be able to see. So we do have a friendly lookalike here in Canada, and that is the white spotted Sawyer beetle you can see on the left. And there are some distinct differences, and I've definitely actually had a number of reports of people asking me if taking pictures of that and of the white spotted Sawyer beetle, and asking me if it was an Asian longhorn. So I appreciate the keen eye of folks. If you encounter this, you can tell the difference, because the white spotted Sawyer beetle is bronzy and dull. It has like whitish patches compared to the bright white spots of the Asian longhorn beetle. Another clue is this little patch between their wings, and that's called the scutellum. And in the Asian longhorn beetle, it's black, and in the white spotted Sawyer beetle, it is white. So what is the impact of Asian longhorn beetle? Kind of just like similar to the the gypsy moths, they'll impact our urban and forest ecosystems. And you know, there are no effective predators for Asian longhorn beetle in North America, so they definitely won't be, you know, controlled through any kind of predation. So they also have really high reproductive rates. And so it's kind of their ability to use this wide variety of hosts. They'll be able to outcompete our native insects, and then also increase the levels of tree mortality, thereby disrupting these ecosystems. So in Ontario, I think in the early 2000s in Vaughan and Toronto, 29,000 trees had to be destroyed in an attempt to eradicate an incursion of Asian gypsy moth, Asian longhorn beetles. All right, movement. They are really weak flyers. If you've ever seen, you know, a white spotted Sawyer beetle or some of those bigger cerambycid beetles, you can see they're not very good flyers. They land on things, can't go very far. They're not aerodynamic, that's for sure. So again, human vectored movement, I'm just kind of bashing this for your heads. You know, once they are on the continent, then the movement of, you know, pellets and materials in wood packaging are responsible for the domestic spread. And then, you know, they are able to emerge out of this, out of the wood packaging, and then go on to infest local trees, which then just, you know, could unfortunately be cut down and then sold for firewood. So my message is burn it where you buy it. And like I said, in Chicago, that first observation was made by a person seeing it emerging out of firewood. So the management and control of Asian longhorn beetle is very difficult, and this is because of their cryptic lifestyle. They're basically always under the bark. They tend to lay, like I said before, small numbers of eggs on several trees, which then kind of makes it very difficult to define like the limit of the outbreak and eradicate the beetle then without, you know, destroying a large number of trees. And so if you do find an infested tree, you can like cut it down and chip it, but really like wholesale felling of infested trees is really going to be a difficult option and not the most palatable. So phytosanitary measures are also kind of key to the management of this. Again, it's the prevention, right? Strong measures have been taken to ensure that wood packaging material from China meets these standards. So is it in Alberta? Well, coincidentally, it was intercepted last spring at a facility in an industrial area, and it was found in infested pallets. And so somebody with a really good eye, I think they squished it, but then called CFIA, and it was confirmed that this was an Asian longhorn beetle via genetics, and a quarantine notice was placed on the material that it emerged from. What is a little chilling, I guess, is that these pellets were stamped with the certification stamp that indicated that they had been heat treated. So is this evidence of a more serious kind of non-compliance violation? You know, that is something that I believe is being investigated by CFIA. So they followed up this interception with visual surveys, I think 750 meter radius around the facility, and no further infestations were found, suspected infestations. So hopefully that was one lowly beetle that had been transported in those pallets. All right, so though that's the end of my focus on those insects, and really basically we're kind of at the end of our time. This has been a long time for you to listen to me talk, and so in summary, you know, I think we can recognize that preventing an introduction is really just the best practice in the first place. Humans are very important vectors, but there are ways that we can mitigate our you know, involvement in the movement, domestic movement of invasive species. Urban trees and our you know, boreal forests, parkland forests will be affected oftentimes by, you know, the same species. And so hopefully you can kind of tell your friends about some of this information that I've provided you with today. Maybe you can form a couple of trivia questions if you're doing any kind of like Zoom pub quizzes. So ultimately, my request is that you inspect recreational equipment if you have transported anything out east, even into the United States, and please do not move firewood. And so with that, we're going to launch the last two questions, or the last poll, which is comprised of 2 questions. And the first being, which was listed as one of the world's worst invasive alien species? Was it A, the gypsy moth? Was it white pine blister rust? Was it the Asian longhorn beetle? Or was it ET, the extraterrestrial? And I see people are starting to vote on that one. And then ultimately, what is my, oh, I don't know if you're able to see that. I'm not sure if you're able to see the second question, but I assume so because people are voting. And this one is basically, what is my take-home message? Moving firewood, firewood transports tree-killing insects. Don't move firewood. Burn it where you buy it. And ultimately, D, seriously, just don't move firewood. And so we'll wait for about 80% of folks to vote, and we're getting really close. And in the meantime, I'll thank you for your attention today. And I'm gonna end the polling, and I'm gonna share the results. And yay, 67 or 81% of you answered A, gypsy moth is the world's worst invasive species, and 100% of you answered question 2 right. So with that, we will just move on to my final slide, which says polls 3 and 4, and then ultimately questions. So thanks again for your time.
Awesome. Thank you so much, Caroline. That was wonderful. Thank you. Thank you. So we do have some questions that have rolled in. So we'll just start at the top. And please, folks, if you have other questions, please don't be shy. Please enter them into the question and answer box, and we will address them right now. So Caroline, the first question is from Kendra, and Kendra is in the MD of Bighorn. Hi, Kendra. She's wondering, are the mountain pine beetle populations in the Calgary forest area low enough that eradication is possible?
No, and that's actually an interesting question. I wouldn't, so their populations are just starting to grow in the Calgary forest area. What's interesting is that mountain pine beetle actually has been, bumping around the Kananaskis and the Waterton Lakes area for a century at least. And so they're actually, more quote unquote native to that part of the province than they are in other areas. And so in this, just kind of given that we have these occasional flare-ups of mountain pine beetle, they're able to kind of exist at low levels for the rest of the time. So no eradication of mountain pine beetle in those forest areas, just for those multiple reasons.
Okay, thank you. The next question I've got from Cam Lockerbie. Hi, Cam. I think this was a comment. It might have been an answer to the poll about what is the best practice for managing invasive species. And his response is, how about denial and magical thinking as per Donald Trump, LOL. So I think, Cam, that answer is incorrect. It is prevention, we learned. So,
magic is always my favorite, as well as denial.
Okay, so Jane asks, so she works in an aspen parkland protected area. What should she be most concerned about at this time?
So I think that you would likely want to just keep an eye out for, it's the gypsy moths, I think, are kind of the ones that would be the bigger concerns to us. But again, yeah, I would primarily focus on the gypsy moths at this point in time.
Okay, thanks. So the next question is from Ravindra, and she's wondering, has any attempt been made to do climate matching modeling, Climex, to study distribution and establishment of gypsy moth and longhorned beetle in Canada or areas in Alberta?
Yeah, most certainly there has been, and I can't give you details on that, but I do know that Alberta, is, I believe from the central region and north, were not actually good habitat for the continued establishment of gypsy moths. It's kind of the same thing with emerald ash borer. A lot of the lower latitudes are the ones that are more susceptible or more conducive, to the establishment of these invasives. So.
Okay, so that's actually all that I have for questions. I have some comments. People are saying thank you for the presentation, great information, great job, Caroline. So thanks for all those comments. A huge thank you to Caroline for spending the time to put this presentation together and to spend her time presenting this morning. It was absolutely wonderful. I know I learned a ton.
Great.
And so, yeah, if there's no other questions, this will conclude our third webinar series, and hopefully we'll see all of you back here, same time, same place, 2 weeks from now. So thanks so much, everybody. Yep. Thanks, Caroline.
Yeah, thank you.
Thanks. Bye.
Bye-bye.